So one thing we can determine on a polynomial function is what's called end behavior. Okay, so think of a polynomial that you know. F of x equals x squared. Okay, so we know that graph, so it looks something like this, right? Well, what we're talking about end behavior is what's happening at these arrows. Notice that it's going up when you go to the left and up to the right. Okay, so that means your output is getting very large when go toward the ends. It's like shooting up, toward infinity. Okay, so what about, let's say you have this function, another one of our common functions, x cubed. Well, that looks something like this. So what's happening on these ends here? Well, when the numbers are getting smaller, it's going down to the left. But when the numbers are getting bigger, the x values are getting bigger, it's going up to the right. Okay, so it has a different behavior. And we can determine the end behavior just by simply looking at the polynomial. Okay, so that's what we mean by end behavior. Now, if you have a function like x to the fourth, and then maybe that's got plus 3x squared minus 7x plus 2. Okay, we're going to look at this leading term. Because it has an even number exponent and the coefficient is positive, that means it's going to look very similar to this. It's going to go up to the left and up to the right. As x values get larger, the output's going to get larger and larger. See, this term is going to be the dominating factor because it's got the highest exponent. We don't know exactly what's happening here in the middle, but we're going to learn more about how to find what's happening in the middle. Right now, we're just talking about end behavior. Okay? So, and then if you had a function like this, something like maybe x to the fifth plus x squared. Well, looking at the leading term, it's got an odd exponent. So this one was even, right? This one has an odd exponent. And so it's going to behave similarly to our x cubed. It's going to go down to the left and up to the right. Again, the leading coefficient is positive, okay? Now, what if it were negative? Let's see if I can have a little bit more room. Let's say you had h of x equals negative 3x to the 7th plus, blah, blah, blah. Okay? Well, you look at the leading term, it's odd, but, oops, odd, but the coefficient is less than 0. So a sub n is less than 0. It's negative. So it's going to reflect about the x-axis. It's going to go up to the left and down to the right. Okay? So this is what we do when we talk about end behavior. And I'm going to give you a chart. It's called the leading coefficient test. So I'm going to give you a little chart here so you'll know. And it's based on two things. First of all, n is even. Okay, that's going to behave like the parabola. Okay? The x squared, that's an even function, and it's got an exponent of 2. So n is, the degree is 2. If the degree is even, okay, then if a sub n is positive, if it's greater than 0, it's going to look just like your basic parabola. It's going to go up to the left and up to the right. And a lot of times textbooks and questions will just write those little arrows. Okay, sometimes I'll write it out in words up to the left and up to the right or something like that. But I like to just use the arrows. If a sub n, which a sub n, that's the leading coefficient. If a sub n is less than 0, then it's going to reflect. So it's going to go down to the right and down to the left. Okay, so think of this like a little umpire or referee, I guess, in football, and he's saying touchdown. But then here's like the umpire in baseball, and he's saying safe, like safe. Okay, so you have to use your imagination. Okay, that's if n is even. What if n is odd? If n is odd and the leading coefficient's positive, then it's going to go down to the left and up to the right. So I usually think of, John Travolta stance here. He's dancing. So up to the left and, I'm sorry, down to the left and up to the right. I don't know, John Travolta gets a hat. Okay. And then if it's reflected, if a sub n is less than 0, meaning it's negative, it's going to reflect. So then it's going to go up to the left and down to the right. Okay. So that's what we mean by the leading coefficient test. You look at the leading term, you have to know if n is even or odd. They just say the leading coefficient test. Okay, so they give us a polynomial. We look at the leading coefficient. It's got to be one of those four situations. Oh, I didn't draw John Travolta going the other way. Now he's like left-handed. I don't know if John Travolta's right-handed or left-handed, but anyway, like that. Okay. So that it's got to be one of those four cases, either both up, both down, or the left is down and the right is up, or the other way. So you look at the leading term. Is the exponent even or odd? Degree 3, n is odd. Okay, so it's got to be one of the two John Travoltas. If it's got a positive leading coefficient, a sub n is greater than 0. I'm sorry, a sub n is 1. That's the leading coefficient. That's 1. And that's greater than 0. So it's John Travolta. It's down to the left, up to the right. And this is a fine answer for my purposes. You can just draw it like that, but you could write it out in words as well.